Hi everyone, good morning and happy Sunday. Today I would like to talk about a very important concept in data analysis, which some people find it difficult or challenging to understand, but it's very, very important in your data analysis career. Okay, and the concept is about relational versus star schema model. I believe this is also going to help the active participants of the 22 days data analysis challenge. You need to understand what you need to do at the level of modeling, because if you don't have a very good model, it's going to affect your visualization or your dashboard. So having a very effective model helps you in order to have a very good dashboard that is, easy to use, fast to use, and just have just the right elements in to answer your business question. So for me to explain this, I would love to use this example. I have an example here. I believe most of you have gone through the four walls of school, university. So just imagine that we have a university that their goal is to manage your data. Ideally, most people would tend to Excel, right? Because Excel already is a very good, you can call it a data management tool, even though it's able to do analysis as well. So imagine this scenario, I just want to keep it as simple as possible. This program manager would like to maybe keep the student names. So I have the student name. You can get the student name, maybe gender, the course they are registering for, and the date of registration. Now, very importantly, there can be 2 or 3 students with the same name, so you need something to uniquely identify a student. In this case, you have the student ID. That is the reason why you were given a student matricle number or student identification number. So I have 2 students here. So Ivo is the first student, and Ivo registered for a course Python on this date. Same again, Ivo registered for another course SQL on this date, and Mary just registered for one course Power BI. Now, there is something not like really wrong, but not ideal if you're using this type of model in order to manage data. I'm going to give you some few seconds in order to identify what is the detrimental effect of using this type of model or an Excel sheet in order to manage your data. Okay, I hope you had it right, but you notice that every time I want to register a course for a particular student, for example, in this case, Ivo, I keep repeating Ivo and the gender male, keep repeating Ivo and the gender male, right? Imagine that Ivo has to register for more than 10 courses, then every time I need to keep repeating Ivo, gender, and then I put the course and date of registration. For those of you that have used Excel, this is what normally you would do in order to store data, right? So ideally, this is not a good data management tool if you're thinking of really having an effective data management tool. So the university might not want to use this. They might want to switch to a database. And to switch to a database, for those of you who have a little bit of understanding of a database is just made up of many tables with columns and rows that are related to each other, that have been designed perfectly for data management. I've taken the time, so I'm just going to have this in mind. I'm going to use that if now I was employed as a database designer or administrator or developer, this is how I will solve this Excel problem using a database. So simply, I will create 2 tables, course student information and course registration. Before I move ahead, you realize that there are 2 important sections of this Excel sheet. This section, so student ID, student name, and gender doesn't change with time. It's just there always. But what actually changes is the course and the date of registration, right? So I will take the fixed part, which is the student information, and I create a table with the student information. The student information will hold the student ID, the student name, and the gender. While for the course registration, yes, I need to know the student who is registering for the course, right? I don't need your name. I just need the student ID, your unique identification, student ID, I need to know the course, I need to know the date of registration. Now, there's something about database. For every table, there must be a unique a column that uniquely identifies a record. In this case, student ID will not uniquely identify a record here because I'll definitely have so many student IDs that are repeating in this table. So I need to create another column called student registration ID. Now, for every table, there must be a primary key. So in this example, in this table, the primary key is student info, while for this other table, the primary key is registration ID. If you are a primary key in one table, in another table, you become a foreign key. Okay, secondary or foreign key, right? So this is how I will, as a database administrator, I'm going to design the database. And when the database has been designed and developed, this is how the records are going to look like. So when students they come the first day of school, they're going to take their student information. So you see, I have student ID, Ivo, and gender. Student number 2, male and female, and that is it. Day number 1, this information is taken. Now, as you're going ahead, they do course registration. So maybe the first semester, so this is student ID, focus on the student ID. This one is auto-generated, okay? Student ID 1, which is Ivo, was registered for the course Python. Again, Ivo, SQL. Now this is Mary, Power BI. And maybe Ivo again did Git and GitHub. So you see that with this, it makes the only thing that repeats in this column, in this table now, is just the student ID, right? Which makes sense. These are just numbers, and computers prefer numbers than text. So if I just repeat the numbers, it will make more sense in terms of data management and data retrieval than using this format where each time I want to do something, I keep adding the same text, so I'm repeating 1, 2, 3, 1, 2, 3, 3 information. But in this other design, what am I repeating? I'm repeating only one information, which is the student ID. So this example of living from that Excel sheet to having a database design like this, it's what is called a relational model, okay? So databases uses what is called a relational model. These are special types of databases because there's also non-relational databases. But our focus is relational model because it's a very common database model that is being used by so many organizations and companies. Now, with this structure, it makes your life easy as a as a data analyst. So most of the time, you join a company not to be designing databases, but to already have the databases that exist already, and the databases will have this model. So your responsibility is to understand this model, and when you've been asked to answer a business question, if there's a database administrator, okay, your role is to go and ask the database administrator, can you please provide me with the relational diagram? So that should be your question. If they're using a relational database, right, you need to see the relational diagram. Why do you need a relational diagram? It's just for you to see, okay, which are the tables I do have and how they are related. And based on that, these are the tables I'm going to need in order to answer my business question. Before you jump into maybe thinking of, you must use maybe your Python, your Power BI, your Tableau, auto programming, or whatever tool. Maybe the business question is a very, very simple business question that you don't need to export the data out of the database. You can answer that question using SQL. So SQL is in full, which means structured query language. It's a language that speaks to relational databases. Okay, so you probably don't even need. You can just use this language and answer the business question. Now, use case scenarios for this model. Okay, so normally we use relational model for transactional databases. So when I talk about transactional databases, these are databases that information is being entered and taken out every day. For example, if I go to a shopping center, they have a software that when I shop and I come my basket, the receptionist or the cashier will just take my items and scan them. It goes into a database. So you see, there's always data entry, and maybe the manager behind the desk or in the office is also able to retrieve the data. So the manager wants to see what is happening in the business immediately live. So you see, data comes in and goes out. So This relational model is ideal for transactional databases where you input information and you take out information just to see. Now, when it comes to data analysis, you don't want to use transactional databases for data analysis. Why? Take, for example, if you have a shopping center where customers they come in, like a very big shopping center that every minute they are doing transactions, they are either inputting information or taking out information. You don't want to run analysis on such a database. Reason being that if you're being asked to what is the sales of last month, right? And you're running analysis and there's someone that is deleting information from that same database because maybe they have to correct an information, then your analysis will never be right or will never be correct. So what do you need to do? You need to export the data that you need to do analysis and into another type of database. Okay, and that is the database I'm going to talk about. But before I move to the other database, I just want to show you an example of a relational model. This is the example I mostly use to Postgres. So this one, so this is a DVD rental, relational model where you actually see the tables. So as a data analyst, this is what they're going to give you to show you that this is how our tables are related. Your responsibility is to be able to identify the tables, how the relationship, how they are related, and which are the tables you're going to need for your analysis. In this example, if you're being asked, please list all the customers that rented a film with the title Romance. Okay, so I know, okay, I have to get, you see, I have the customer table and I have the film table to my left. So for me to answer the question I need to leave from customer, I follow the arrow, I go to rental. From rental, I go to inventory. For inventory, I go to film. So to answer that simple business question, which are the customers that rented out a particular movie with title X, I need to go through 4 tables. So as a data analyst, that's your responsibility. Your responsibility is not to design a database like this, it's just to know how to understand a database and get data out of it. So this is just an example. And also I'll see this opportunity to talk about our trainings. I really emphasize that you learn from industry professionals, because with an industry professional, some of the insights I'm giving you, maybe if at school you will never see them, but from an industry professional, they have done this like for many years, and they have understood some of the challenges and how they solved it. So when they're actually teaching you, they will just go straight to the point and help you with those kind of tips. And these are the kind of things that maybe when you go for an interview, the employers, they're asking to find out if you have some experience, if you have faced these challenges before. Do you know how to resolve this kind of information if you're this kind of challenge if you're faced with something? Okay, so you see, we do offer these types of trainings such as business analysis, data analysis, and for the concept I'm teaching you right now, it will fall under database and SQL. Okay, where you cover all the database, like a database design, in this case not like a design but a relational model, and also the star schema model. You do the relational model and how to get data out of a relational database for analysis using the SQL language. And for the next model I'm going to talk about, we'll cover it. If you're doing a whole program such as business analysis or data analysis, you're going to see that for me to do analysis, I need to use another type of model, which I'm going to talk about now. Okay, so back to our drawing board. So now I know, okay, this type of database, transactional databases that uses relational model is not ideal for data analysis. Which type of model is ideal? So we have the star schema. So the star schema model, just as the name suggests, is just, let me use a clean section. So I have something like this, something like that. I hope I'm a good artist though. So at the center of the star schema is what is called a fact table. And at the edges of the star, we have dimension tables. So the fact table is just a table that, just as the name suggests, it contains the core facts of the business. Okay, it contains detailed information about everything you're doing about the business. That means it's the table that information really gets in there really often. Okay, in our example, if I'm to define the fact table, then it's going to be my cost registration table. Why? because you see, I have detailed information every day or every time they register a student. There's a new, not like a student, a new course registration. There's a new entry, but this guy stays fixed. Nothing changes. It might only change at the beginning of the year, but this guy or this table changes based on course registration. So as more students are registering, they have to enter information here. Now, I can extend this database and I say there's another table called lecturers. Lecturers will always stay the same. Let's say at the beginning of the year we had 5 lecturers. Ideally, they will stay to the end. So the lecturers will just be there because the lecturers are the one teaching the courses, right? So the lecturer stays the same, but what actually changes is this. So in our example, the fact table is going to be our course registration table. And an example of a dimension table would be the student info. Another example would be lecturers. If I'm using a full-blown database, another example could be, in my example, I did not put student address or maybe classrooms because courses need to happen in classrooms, right? So stuff like that. So, but my core will be fact course registration in this example. So if you have to do data analysis, you need to understand which table is your fact table. Very, very important. So the fact that you cannot do analysis, ideally you should not do it directly on the transactional database. You need to export the data into another type of database or to your tool. When exporting, you need to use the star schema. And the star schema is, you first of all identify your fact table, which becomes a core table, and you have the dimension tables. Okay, so that is about star schema. Now, tools like Power BI actually uses this. They use this at the core of the data analysis because the star schema model is ideal for data analysis, very, very ideal. And also other types of databases such as warehouses, data warehouse. So data warehouses. This is the type of model they use. Okay, they use the star schema model because it's ideal for data analysis. It's just ideal for data analysis. So basically, just to say this is just the difference between the relational model and the star schema model. Maybe I'm just going to show you. Yeah, it's going to be a little bit. This is not an ideal one, but if you just Google star schema, you see this is maybe an example of an inventory database where you have the sales table at the center. The way I usually identify my fact table is most of the time you will have the date, like the date. You see, sales territory, there's no date. Product, there's no date. It's just, yeah. Employee, there's no date. Reseller, there's no date. The dim date is when you're doing star schema, they always says ideal to have a calendar table. So this is the calendar table, but you clearly see that in this case there's a ship date, right? So when the transaction was done, when was the thing shipped, and the order date. So you have the order date, the ship date. So in this case you identify the fact. In fact, I've already labeled it as fact even. But when you're importing from a transactional database, you are not going to have this fact with dimensional tables. But when you're designing in a data warehouse, this is how you design your data tables to let everyone understand that it's a dimension table, it's a fact table. So maybe also you might join a company and they already have a warehouse. So when you have a warehouse, they already have the tables labeled like this. So all what you need to do is to just understand that this is the fact table and the rest are the relational, are the dimension tables. Okay. So that is that. I don't know if I have something else to show you here. So just like summary, so the relational model is ideal for transactional databases. It's just where you enter information and you retrieve information, and most of the time software uses this software that are like shopping centers. Behind the scene they have a transactional database or with type relational model. Now for data warehouses, which is ideal for data analysis, so they'll have the star schema model, and for the star schema model you have the data warehouses, right? I mentioned the data warehouses or data lakes. So you take information out of the transactional database and you put them into a data warehouse. And the data warehouse is made up of, they design it with the star schema model in mind. So guys, this is what I had for you today. Very, very important concepts when you're doing your data analysis. So always use the star schema. I know this is the concept, so you probably want to research more, or why not come to us, take one of our trainings, and we'll show you how to actually do this live using any of the favorite tools such as Python, SQL, or Power BI, or Arrow programming, or whatsoever. Okay, I thank, yeah. So if you do have any questions, don't hesitate to put them in the comment section, or maybe reach out to us directly. And like I said, pick up one of our trainings so that you really master this and become a pro. Thank you. A nice day.